Hello, and welcome to the April 5th, 2021 Bitcoin Cash Network Discussions.
It's
These
still
meetings
saying,
serve...
Sorry. It's still saying,
Oh, yeah.
Setting up the link between Zoom and YouTube. Okay.
Oh, then now it says streaming, so
Yep.
maybe
Said to me,
we're on
webinar is now streaming live. So
Okay.
this might be
Well,
very
hello.
Sorry.
No problem. Welcome to the April 5th, 2021 Bitcoin Cash Network Discussions. These meetings serve as a public forum for discussing initiatives that have an impact on the Bitcoin Cash Network. This is not, however, a place where official decisions are made, of course, for the whole ecosystem, nor do we officially represent Bitcoin Cash. Bitcoin Cash is a decentralized network, so there's no such thing as an official decision outside of the blockchain itself. Instead, our goal is to help establish a high bar for proposals while also providing a platform for public moderated discussion. Today's topic is the group tokenization proposal presented by Andrew Stone, lead developer at Bitcoin Unlimited. We're also joined by Bitcoin Cash Node contributor and BCH Services operator imaginary username, as well as Calin Culianu, maintainer and developer for Bitcoin Cash Node, Electron Cash, Fulcrum, and many other things. So the discussion will be conducted in several sections, and for each section, the presenter, Andrew in this case, will give an overview of that section of the proposal, and then our guests will have the opportunity to add their own comments and ask questions. So those 5 sections will be 1, the proposal's problem statement and or use case, 2, the properties of a good solution and or implementation, 3, the proposal itself and how well it fits those requirements, 4, the cost of the proposal to the BCH ecosystem, and 5, we'll discuss the relevant stakeholders and any public support that they've already shown. So Andrew, whenever you're ready, please go right ahead.
Sure. So I'm going to try and share my screen here. Okay. Okay. So of course, as was previously said, this is about tokenization for Bitcoin Cash. Let's just move right to the first slide. Okay, so quick overview is group tokenization brings first-class miner validated tokens to Bitcoin Cash. Why would you want to do that? Well, you know, tokens have proven significant demand. They seem to be one of the main drivers of Ethereum price appreciation, frankly, and also a lot of other altcoins are moving into tokens. It seems like a reasonable thing to imagine that the world will start working with tokens to represent real assets in different ways, and also more abstract representations for tokens, like the whole art, NFT art craze that's happening right now. When might this happen? Well, you know, in this decentralized network, there's no real guarantees, but, you know, I'm personally hoping for November 2021 with a fallback date of May 2022. How do we plan to do this? Well, what we want to do is create a very smooth upgrade from SLP 1.0 tokens to SLP 2.0, and there are certain aspects of, you know, the group tokenization architecture that makes that easier. So I think this is sort of the first slide for us to discuss. Problem statement. First of all, and perhaps most important, it fixes issues with SLP tokens. I was actually asked by people working on SLP to reinvigorate group tokenization, which has, you know, was proposed many years ago to fix issues that are affecting SLP tokens today. So I predicted a lot of these issues, so I may perhaps use some terminology that is a little different, but the first and most important one is what I call silent forks, and that is cases where 2 clients deviate in their interpretation of SLP state. And so that effectively is a fork in the SLP blockchain, but since there's not a, you know, proof of work consensus mechanism, that fork is not detected very easily. So that's why I call it a silent fork. Another issue with SLP is you can have accidental token burns when or token loss effectively, when a wallet that doesn't understand SLP spends the underlying Bitcoin Cash UTXO as Bitcoin Cash. And then also SLP tokens don't admit to SPV validation. So, you either need to trust a full node that provides the SLP data, or the validation speed can be very slow because you need to search through the whole history of that SLP token to validate that it was properly transmitted between every single owner since its genesis. What else? Why else have tokens? Well, to increase BCH blockchain wallet adoption, I think this is really important. If we can put more wallets on phones, then we're going to be putting Bitcoin Cash in front of more eyeballs every single day. And so if tickets or, hedging or, hypothecated US dollars or other securities are, presented to people through the Bitcoin Cash blockchain, then they will be exposed to Bitcoin Cash. And then the third advantage, again, is the problem is to create more adoption, right? Broaden Bitcoin Cash use. So I think group tokenization does that in 3 ways. One is, use of, so to use BCA, tokens on Bitcoin Cash, you would need to hold some Bitcoin Cash for a variety of reasons. And actual use of Bitcoin Cash results in high quality holding. And Bitcoin Cash will be kind of like the oil that greases this whole system. And also it will be the, like the currency of last resort. It will be the currency that everyone accepts because it's the fundamental native currency on the Bitcoin Cash network. So it would be your most common counterparty between token trades and so forth. Secondly, transaction fees and dust limit. So, every token turns out, of course, has transactions on the blockchain that pays transaction fees in Bitcoin Cash. And also for every token, a little tiny bit of Bitcoin Cash is also associated with each token. And that does consume and use Bitcoin Cash. So finally, I talked about this a little bit in the first point is, Bitcoin Cash becomes the most efficient medium of exchange within a token ecosystem. So I think in summary, if we create better cash on Bitcoin Cash, it will create a better store of value. And I think actually that quote should have been perhaps our Bitcoin Cash's talking point, our motto from the start, right? We've been so focused on cash uses, we sort of forgot that Bitcoin Cash is just as good of a store of value as Bitcoin, but it could be even better because it's also cash, right? And so perhaps we should sort of bring that idea to the public's mind through different technologies, group tokenization being one of them. That's it for this slide.
John, I see you speaking, but I don't hear you.
My apologies. I turned my voice down so that I don't cough into the mic. If you could stop sharing your screen so that we get everyone back. Thank you very much.
Yes. I'm actually not quite sure how to stop sharing screens. Oh, there it is. Here it is. Got it. Okay.
Very good. So I think a good place to start would first be questions that either of you have directly for Andrew about either his intent or what he means. Calin, is there anything that you'd like to start with along those lines?
I mean, I think it's pretty clear. I understand what what he's saying. I don't have any questions right now. No.
Imaginary?
So I want to address the very first point, which is that silent forks, aka different interpretations of token states, have indeed happened on
Okay, and actually, I apologize, Imaginary. Just so we can stick like strictly to the format. It sounds like this isn't going to be like, is this going to be a directly like, hey, what did you mean by that? Or is this like moving on to comments and suggestions / or just comments territory? Is that right?
Oh, okay. I'm making a comment.
Okay, yeah, and that's fine. I just figured I'd make sure. So we'll go ahead and move on then to that, and then we'll get back to Calin. So please go ahead with any comments, and we'll go back and forth.
Okay, sure. So I just want to address the silent fork point, which I have personally witnessed was a thing that happened on the SLP ecosystem. Different clients have interpreted states differently, which led to a quote unquote fork, a disagreement, which was a problem. So I want to note that in a consensus-based token system, because it's consensus, interpretations affect whether a node view a chain as valid, and that is independent of proof of work. So no proof of work does not resolve this. In fact, if different clients have different interpretations towards token state in a consensus-based system, it will lead to a blockchain fork. So a problem that was previously a token system problem is now a problem for the entire blockchain. So I just want to bring that up in the correction. And
sure, Andrew, do you have a response to that?
Yes. So that's he's sort of exactly agreeing with me. I call it a silent fork, right? So in fact, exactly what he says is what will happen. You will have a very obvious blockchain fork. I argue that that's actually better because it can be, we've actually had them in Bitcoin before, right? They're discovered rapidly and they are handled versus a fork that no one notices except for the person exploiting it, stealing potentially millions of dollars for months until all of a sudden there's no going back because the blockchain has advanced for months.
That is.
So would you argue that? Oh, I'm sorry. Go ahead.
That is an interesting interpretation, I must say.
Well, you can ask yourself, why didn't Satoshi do it that way? So one thing about group tokenization is that it is following the Satoshi architecture for tokens. So for any question like this, you can say to yourself, well, why did Satoshi not, have a problem in the blockchain create a hard fork? Why didn't he just allow, and this is actually what the Bitcoin white paper begins with. He says, let's propose a timestamp server, right? So all a timestamp server does is it orders messages, right? But the blockchain is much more than just a timestamp server of messages, right? It enforces certain consensus on like quantity of Bitcoin Cash. So you could ask yourself, why didn't Satoshi do it that way?
That does not make any sense. Bitcoin Cash is explicitly a minority fork that disagree with majority proof of work on consensus rules.
If I could interject, Andrew, would you say it's accurate that what you're arguing is that it's not that it prevents silent forks, but instead that, well, okay, you could say it prevents silent forks, but I guess the point you're making is that it makes it so that they're not silent. And instead, exactly. The point you're making is that they're visible as opposed to invisible. And yes. if that's the case, then Imaginary, does that change anything? Do you understand what he's getting at there? Have we lost you, Imaginary?
Sorry, I'm here. I thought you were addressing Andrew.
Okay, so I sort of did, but then so it seems like you're saying yes. So it seems like the main point was that it makes it so that forks like this are, it's not that it doesn't prevent them from happening, but it makes it so that anything happens obviously and publicly. Yes, and I just wanted to make sure that was it. Okay.
Yes, and it massively impacts the confidence of the entire ecosystem, including BCH itself, instead of having a problem that is isolated to one token system.
Okay, so go ahead, Calin.
Yeah, so I mean, it sounds like the question before us is, do we want to make tokens a first-class citizen as important as UTXOs are, right? Because we'd have to accept the risk of forks in the blockchain, but the advantage is that the complexity of tokens would be concentrated in just the node implementations, right? Which would tend to be of higher quality as implementations. You have smarter engineers working there, and you have like a finite number of nodes, right? How many implementations are there? 5. There are like 2 major ones, and then there's smaller ones. And you sort of have less risk there, right? Whereas when you don't have the tokens as first-class citizens, where you have everybody has to sort of implement all these crazy consensus rules to do tokens, you're just gonna. I think it's more likely to get what Andrew was saying. It's more likely to get silent burns and silent forks. I mean, the question really is, do we want to make tokens first class? And if we do, we probably should put proof of work behind them, and we should put, we should have the nodes doing this kind of logic, not like, Bitcoin.com, JavaScript, whatever. Like, I don't know. That's how I see it. Is just, do we want them to really be first class? And then if they are first class, what are the impacts of that in terms of performance, really, or other things like complexity? I don't know. That's just the way I see it.
I agree that is a key issue. But that key issue can be phrased in a way that sounds very different. If one is in favor of such a proposal, one would say that the problem is whether tokens should be first class. If one is not in favor of this proposal, one would say that the question is whether the benefits to tokens are worth the straight increase in risk to BCH itself, because they are now brought under similar risk paradigms.
Right. So what is the risk? I guess added complexity, right? More complex rules to implement a node to do consensus. Is that part of the risk, or what are some of the risks that you see?
Oh well, I'm strictly speaking of Andrew's slide just now, and that is a risk that is present in that has been seen in SLP, and naturally is also a risk in a consensus system. It will be explicit, and if it happens, there will be a huge confidence hit. There is no way around it.
So Imaginary, it sounds like what you just said was that the problem he described is still possible with minor validated first class tokens. But it seems like what Andrew's saying is that, at least the way he's phrasing it, a silent fork would never happen because it would be a real fork, which he's arguing anyway is actually a benefit. Do you think that's accurate, Andrew? And if so, would you like to add?
Yes. So I would like to add one more thing to the context of this discussion, which is I personally believe that we're not talking about do we have silent tokens, like popular silent tokens, like non-SPV style, non-minor validated tokens, or first class tokens. And the reason why is because tokenization proposals are entering other blockchains, and they will be first class citizens. So if you are a entity and you're wondering where you should place your token, if we don't move to a tokenization system that's minor validated and first class, I believe that people will choose other blockchains, right? And now they may choose Bitcoin Cash because they've chosen Bitcoin Cash and then put tokens on, right? But if we want tokens to be a driver of adoption and excitement around Bitcoin Cash, then we need them to be competitive across all sort of blockchains, right? And so if we are not competitive, then they won't drive adoption of Bitcoin Cash.
Well, Andrew, could you maybe speak a little bit to then the very basics of the cost benefit. And maybe, we'll get to more of this later, but so there is, of course, with any addition of complexity going to be risk. And it seems like, so, okay, however you phrase the question is, should they be first class citizens, or more, should we take this potentially enormous risk? But as far as the risks go and the rewards, could you maybe tell us a little bit about why you think it's like definitely worth it or mostly worth it?
Yeah, so group tokenization, and I'll describe this in a later slide, uses an incredibly simple algorithm, and it is in consensus, right? But it is something that a high schooler could write. We're effectively just looping and adding and then doing a few if statements. So this is not, complex cryptography, nothing like this. So I think, and additionally, the constraints that have been added are all additional. So like existing constraints were not modified, right? So for example, if you literally don't touch the code that enforces quantity of BCH, right, then you can arguably, looking at a particular code, say, there's a proof of correctness where I added this additional constraint and I didn't modify an existing constraint. So how can my adding an additional constraint cause, break an existing constraint? The answer is, you can look through the code and sort of prove the correctness of it and show that that's not possible. So I think that the code changes here are very small compared to the value that is achieved. And there's more of that in other slides, so maybe we should just pause there.
Sure, that sounds good. And I'll give Imaginary and Calin one last chance for any closing statements on this section. And of course, if you want to comment, a little longer on the same subject, please go ahead.
I would just, there are other things, but I would just like to point out that adding constraints on top of additional consensus constraint is usually otherwise known as a soft fork, and it is pretty difficult to argue that a soft fork cannot be harmful. That is generally not how it works.
Sorry, can you repeat that last statement?
It is pretty difficult to argue that because it's soft fork, it is not harmful, and that is not a thing.
I didn't say it was not harmful. I said that it cannot break an existing constraint. But there's no doubt that a bad implementation could be harmful in some other way, but the way it's harmful is constrained.
Okay, well, given that, let's move on. I think that's probably a good spot, if you'll excuse me. And of course, hopefully we can continue things online and in later discussions. But let's move on to the next section, which is the properties of a good solution. And so Andrew's going to walk us through what he thinks the properties are. And of course, Calin and Imaginary will have the chance to respond. So Andrew, please go ahead whenever you're ready.
Okay. Sorry, I will get used to doing this. Solution properties. So it needs to implement tokens, non-fungible tokens, fenced Bitcoin Cash, and script covenants. It should contain space for expansion of other interesting features and ideas. Be first class or native. We've been already talking about these terms. What that kind of means is it provides the same functionality for tokens as for the native cryptocurrency, and in sort of a very fundamental way. And by being so fundamental, it kind of so this is the last point, leverages existing BCH scripting. Like, because it's so fundamental, it won't interfere with new features that get added. They will complement, if they complement Bitcoin Cash, they'll complement group tokens as well. It's very efficient, allows at the client level, minor validated SPV proofs, as we said, eliminating silent forks, and it uses minimal blockchain and script space. It does use some blockchain space, of course, but you're not executing a script to enforce token properties, so the script space is very small. It's easy to use. The programmers don't have to write these complex scripts. And also it's an idea that maybe a lot of people haven't really considered, but if you're on Ethereum and you invest in an ERC20 token, that is actually an abstract interface, and the developer goes in and implements what that is under the covers. And sure, there's like a recommended implementation, but you can implement anything you want. So technically, every single time you grab an Ethereum ERC20 token, you really ought to do a code analysis of that particular token's implementation to make sure that it doesn't have security flaws. But with a single implementation that drives all tokens outside of the script layer, that problem goes away. I've mentioned briefly, the consensus changes should be isolated from other changes. And then also, a real nice to have is a clean upgrade from SLP v1 tokens, so that we can minimize the work needed to move from SLP v1 to SLP v2 tokens. That's it. You're on mute.
John?
Thank you. Yep, I'm probably going to forget a couple more times, but probably better than me coughing into your ears. Sorry about that. So, Calin or Imaginary, first let's start again. Does either of you have any questions, just as far as clarifying what Andrew meant or what was intended by that slide, just so we can get that out of the way first?
I have no questions. It seems pretty clear. I mean, I have some background in it, but yeah, it seems no questions for me.
As far as meeting goes, I don't think I have any questions.
Okay, then we'll move on to any general comments or additions. So, Calin, do you want to start there if you have anything to add?
No, I mean, I agree with that list. I just want to comment that, yeah, it's nice to have to not have to write a complicated script to implement a token, like Andrew was saying, where if you have it in as the node's rules, the node's logic, and C++, a very simple implementation to do tokens, which is nice. I mean, SLP has that now, but yeah, I agree with that. Just wanted to comment that I think that's a good strategy. I think that could be attractive to people trying to decide what coin to use for tokens. If it's easier to implement, it's just another. I mean, Ethereum is really hard to do, so that sounds like a benefit. But that would be the case with SLP too, aside from SLP's problems. So.
Sure. Imaginary? So aside from SLP, which itself, it literally has simple in its name, I also want to address the supposed difficult that is created by, script-based tokens like ERC20. The reality is that once you have a standard based around a common template for creating a specific type of commonly used token, and people have looked at it quite a few times and generally accept that, okay, this is simple enough, and this is simple enough and have passed enough eyes. The marginal cost, the marginal complexity for reusing this template over and over again is really minimal. I mean, at the height of ICO craze, I remember there were services on Open Bazaar that you can pay people like $100. You literally don't need to know anything about cryptocurrency or tokens, and people would just press buttons to make your tokens for you, and it's that simple. Nobody cares about what the underlying script looks like. It's all standard. So
yeah, it's a template. Yeah, usually, yeah, that's true.
Yeah. So whether the underlying script is more complex or more simple, has an impact on fees. it has an impact on size. But complexity-wise, once you get to the margins, I don't think it matters that much.
Andrew, do you have a response?
Well, people outsmart themselves and they say, oh, I'm just going to use this template with just 1 or 2 small changes, right? And, or they deliberately introduce, changes in the hope that people won't notice, right? You just don't know as a token purchaser whether the template was adhered to unless you, unless you like examine the code, right? I teach a course on blockchain and we go through Ethereum, and I've seen so many bad tokens. I hope it's something that we can do to differentiate Bitcoin Cash from Ethereum, right? We need to do something. And I certainly have seen bad token implementations. Maybe it's because, I'm working with students.
Well, I mean, a wallet can choose to verify that a wallet can choose to verify a template just as easily or hard or as difficult as verifying a multi-sig template, which is P2SH script. People can, of course, do weird things theoretically in a P2SH that is supposedly multi-sig if they want to, but that has not stopped anyone from using multi-sig ever. So, yeah.
Yeah, I mean, most wallets just give up if they don't understand the P2SH, if it's not a standard template. So that's an advantage, right? They're just like, I don't understand this. So that's the advantage.
Yeah.
So is there, and this was open for any of you, is there a fundamental difference between the fact that in the case for Bitcoin Cash and the thing we just described, we're describing a smart a script associated with an address to which one is receiving, as opposed to a program that someone else has made for you? Does that make a difference in how much trust is really required, or whether it's marginal or not?
I mean, just naively, it seems like it's just easier to verify. You just see the OP group header, and then the rest of it is just a normal address. I don't know. Does that answer the question, or I don't know. Who are you directing the question to?
Yeah, that was for anybody, because
Okay.
it could have been.
It's just a lot easier just to even look at. Like I don't know. You see like a couple of bytes at the beginning, and then the rest of it is just a standard address. It's just like really like that simple. Maybe I don't know. Question.
Fundamentally, all transactions, no exceptions, are paying to scripts. Even P2PKH or all the very simple ones we talk about, they just happen to have really short scripts, and that's it.
Right, that's an important point to clarify. Yeah, Bitcoin uses scripts anyway natively, but they're all very short or simple. They're not.
And maybe it looks like, so the question, it seemed like the point, and correct me if I'm wrong, that was being made, imaginary, was that, so well, okay, if I to just summarize very quickly, it seemed like Andrew was arguing that there's a risk in using, maybe small, but there is a risk in using tokens built on Ethereum because their smart contracts can be written in a way that, unless you verify, might be a problem for you. Now, from there, you brought up script templates, and actually maybe that's worth doing. Would even maybe this is a good one for Calin, but anyone else too. Could you explain what exactly you mean by script template? And I realize we don't want to get too technical, but it seems important for the discussion. So does that mean that an Ethereum wallet can make sure that a token is following a very specific smart contract template? I'm
not actually as familiar with Ethereum as Andrew is, but I assume that.
Okay, well, if you don't mind, we can ask. Let's ask Andrew. Is that the case?
Sorry.
And maybe even this shows just a fundamental misunderstanding on my part, in which case we shouldn't waste time on it. But if I'm not following, then I figure some people might not. So the point you were making before is that, so Ethereum, for each Ethereum token, it has its own rules about how it can be sent around. Is that correct?
Right. So you would have to look at the program underneath the token and analyze it, right? And you can do that. So, it's on the blockchain, right? But with group tokenization, since the enforcement of the token rules is not in the script, right? All you have to do is look for the op group instruction at the beginning, and then it's going to enforce this token just like it enforces all the other tokens on, the Bitcoin Cash blockchain.
So there's a consistency there that you can rely on. Okay. And so imagine maybe you could then just even just reiterate your point that your argument that it was a marginal or not important risk.
So it is true that I mean, obviously, if you have a shorter script, it's easier to verify. That is generally true. But keep in mind that on Ethereum, the reason that often you get all this risk that is associated with different contracts and tokens that are involved in different contracts is because of the huge variety that is present out there. If you use something standard, then there is no good reason that it cannot be as easy to verify using just a common standard as group or any other implementation. So if on Bitcoin Cash, for example, if we toss a few more things into script and say that, okay, now we have this huge variety of ways to encumber tokens with different conditions, different scripts, different mechanisms, then those will also be difficult to verify. Perhaps because of the opcode limit, they will be a little less so, but
maybe this is a clarification. By verify, imaginary, are you talking about miners verifying, and Andrew, are you talking about a user verifying?
I'm saying in the context that Andrew has presented, which is that users verifying the script, that there are no shenanigans or rug pulls that are present.
So I kind of disagree with that, and it's the same argument that I had with the hard versus silent fork, which is that the group tokenization is adding a rule, right? So now in this script context, if you use op group and you have removed all the mint authorities, so there's no more sort of mint ability, then you can write any script you want, but you can't actually mint any more tokens. It's not possible. So the system, you don't have to, if what you're worried about is that this token may become inflationary, you don't even have to look at the script, because you can look and say, well, there's no more ability to mint this token in the system by looking at UTXOs. I don't care what's in the script, because I know that the conservation of token quantity is enforced by op group. Don't need to look at all of the additional rules and interesting, fun things that this token actually implements.
That is a very specific vulnerability that is addressed using a very specific solution. But generally speaking, for a given user, whenever you get tokens that happens to be spendable where they don't expect it to be spendable, any such incident has potential to be just as harmful as rogue minting, as you described.
I think we're just going to have to agree to disagree on this, right? I think that preserving some fundamental properties of a token in a very simple way provides a lot of value. But you're not wrong that if you're worried about someone's imaginary username is not wrong. If you're worried about someone somehow being able to spend a token that you're holding and there's a complex script, you would have to examine that script to make sure that there's no ability for someone else to spend the token that you think you own, right? But you wouldn't have to examine the script to sort of to validate that the token's properties of conservation and so forth are maintained.
Well, that seems like a good place then to move on. Now we've covered these properties of a good solution, and the next section will then be the details of the current proposal. So group tokenization, specifically in the context of those priorities. So Andrew, whenever you're ready, if you could walk us through how exactly you think group proposal fits those.
Okay. So basically, this is at a very high level. I think many people are already aware, but effectively what group tokenization does is it annotates the outputs with a little bit of data, right? A group identifier, the quantity of tokens, and then an opcode called group, okay? Now, so here's a pay to public key hash example. So normally, pay to public key hash looks like dupe, hash 160, your address, equal verifying check sig, okay? So in order to create that exact pay to public key hash, but for tokens, you would do a group identifier, the quantity of tokens, op group, and then you do that exact pay to public key hash script, right? So all you're actually doing is annotating the beginning of a script. And it's actually, you shouldn't think of this as an opcode that actually executes. Inside the script interpreter, all this opcode does is pop its quantity and group ID, right? We had to put it in the script because due to the structure of the Bitcoin transaction, there's no other place to put anything. And that may be an issue that will be addressed, years in the future where we create a whole new transaction format. And when we do that, we could, maybe clean this up, right? But I don't think personally conflating cleanup with this new feature makes a lot of sense. So this is, the sort of most efficient path to get this functionality.
And Andrew, if I may interrupt you, just to clarify, so the when you say annotating, that's a labeling. Is that accurate? Is there another word that you could use that would?
Yes, it's effectively a label. Yes, and so then and that label is not used within the script interpreter, but within the transaction level consensus, right? When transactions are analyzed for correctness, it is used. And what happens is basically at the transaction level, you have a loop that says go through all the outputs and sum up all of the quantities per group, and then go through all the inputs and sum up the quantities that came in. And guess what? Let's make sure they're equal, right? And this is why I'm saying that this algorithm is something that a high schooler could implement, right? And now there's a little bit of complexity with the minting and melting, which I don't want to go into in this slide, but basically the same sort of idea is when you create a group, you create certain authority outputs that allow you to mint and melt, and you need to spend those in order to do a mint or a melt. And basically to do a mint or melt, it basically says, that loop and that compare that we were doing, well, if you have the mint authority, don't bother to do it, right? Or you can allow there to be more outputs than there are inputs. And if you have the melt authority, you can allow there to be more inputs than there are outputs, right? So there's this one qualification, which adds a little bit of complexity, but it's still fundamentally just iterating through the inputs and outputs and seeing if they balance, qualified by, oh, I found like a special authority, so I can ignore this restriction. That's it. That's the proposal. And, there's no, I'll talk a little bit later about the effects of this in the next slide. So let me just stop there.
Maybe before you leave the slide, I would like to point out, ideally, we would sort of go through this and directly reference back the properties in the previous slide and how group lives up to them. So if you'd be willing to, maybe we could just even do that now.
Okay. So it's a little bit, so the thing is that, you're going from the proposal details, you're going from 0 feet above up to 10,000 feet, right? So sometimes it's hard to understand how the properties emerge from this, right? But at the transaction level, this is enforcing that inputs equals outputs, right? And so what that basically means is that you cannot, oh, and you're annotating things with a group ID. You can consider that a token ID, right? So a token might be a single entity of something, and the group is like if you have mint 1,000 tokens, that's kind of like your group. So you have a group of tokens, right? That's the terminology. So it certainly implements tokens. You can see by the annotation. NFTs would be a token ID of 1. And then also there's an additional little feature here, which is that group IDs can be, you can implement something called a subgroup, which is you can just add a few bytes to the end of your group ID to create a larger ID. And that's interesting because not only does it produce non-fungible tokens, but you can specify what the custom bytes are for your NFT, right? But not too many bytes, but you could have, like, for example, a hash as, part of your NFT group ID, and that hash could refer to a document, right? Or if you were issuing NFTs as seats, right? Then your group ID is like the show, right? And then you could have a few bytes at the end of the token, which specifies the exact seat that the person's sitting in, stuff like that. So this whole system will also enforce the same rules for Bitcoin Cash that is in the same UTXO. If you set a particular bit in the group saying that's what I want. And so that's what I call fenced Bitcoin Cash, right? And the use of fenced Bitcoin Cash is a little bit esoteric, but it's basically, you can throw a bunch of Bitcoin Cash into into like a group. And so then you can have rules about how it can be spent, right? And so it could back some other token or something like that. Script covenants. I didn't actually mention that in the details. There's one more kind of rule, which is if you have a bit set in your group ID that says I want covenants, then what happens is that the system also checks that the output script matches the first input script that's grouped. Okay, so again, it's just a simple check. And so then all of a sudden, so what a covenant is it's a script that sort of passes from inputs to outputs, right? And then recursively. And so that's enforced by a simple check. So first class native. So as I said, all of this is implemented at the transaction level consensus. So that's what makes it like first class and native. And there's this exact same code that actually checks the quantities of Bitcoin Cash. So this is literally kind of like it's analogous to what the code that's already existing in Bitcoin Cash. So efficient. So because the miner is enforcing the quantity, and it's not like in an op return where the miner ignores the fields, right? The miner, if this quantity doesn't match, or group ID quantities don't match, then the transaction is rejected. So that means that if this transaction is committed to a block, then the miners agree, and that block has sufficient proof of work, right? Then, it's overwhelmingly likely that that transaction is valid. So you can provide an SPV proof of that transaction, just like you do with Bitcoin today. So uses minimal blockchain and script space. So basically, a group ID is the hash of some data. It's a hash. So 32 bytes there, and then the quantity can be 2 to 8 bytes, and then a single operand, a single byte called group, right? So you're implementing this with about 40 bytes per output. And that's pretty small if you think about implementing something like this as a script, right? Because you'd have to have a lot of logic. but that is going to be discussed in the trade-off. We are using more space. But I think it's pretty much as efficient as you can possibly get. Easy to use. Again, I just taught you guys how to create a group transaction right here. Boom, done. Right. So for wallets and things to handle this, it's very easy. And it sort of adheres with existing conventions of these simple scripts that wallets deal with. You as a wallet don't need to worry about validating it. You just need to ask for the SPV proof of its inclusion in the blockchain. Isolated consensus changes. So in the details, you didn't see anything about how I was monkeying with anything else, right? All I did was add a restriction, which is this looping operation, right? So no existing consensus rules were changed. And finally, the clean upgrade from SLP v1. So a little bit of the history of SLP v1 is, group was proposed, and then SLP came out as a way. SLP v1 actually mentions like the white paper mentions group as like a good minor validated solution. So it actually is using the blockchain in a similar way. The only difference is that the rules and annotations in SLPv1 are located in this op return area, which is not minor validated, and group tokenization pushes them into the outputs and minor validates them. So basically, compared to other approaches, it's a much more natural upgrade because it's just the same data located in a different place and minor validated in one case and not in the other. So that's why the details meet the properties.
Thanks very much. And so I realized that, of course, having already gone over, the properties themselves, then maybe there won't be a whole lot to say about groups specific implementation there. But please, go ahead, Calin.
Yeah, so I have a question. So obviously semantically this maps onto SLPv1, or SLPv1 maps onto group, right? They both like tag UTXOs using a different mechanism, right? Would you say that's correct, Andrew?
Yes. So
now a really, really naive question. I think I've said this before. What's so terrible about just making SLPv1's OP return the stupid OP return it does, right? Or you can argue it's stupid. It's whatever. It's functional. It's a place to put data. So they put the data in the OP return. They tag the UTXOs in this. Why not just make that minor validated? What is so terrible about that? I'm being devil's advocate and asking this, but yes, why is that so terrible?
Right. So it's an option, and I guess it comes down to sort of how ugly you want the code to look like, right? So there's sort of some rules that op return is supposed to follow, right? Like, for example, it's not supposed. So there's some basic rules, like no UTXO can affect any other UTXO in the system, right? So we're totally breaking that rule, right? Because separate UTXO, right? Okay. So now what you effectively have to do now in like your UTXO database is you have to somehow annotate a UTXO and say, oh, but really this UTXO depends on data from this other UTXO, right? So that's a huge mess. Or what you could do is take the data from op return.
Right, that's what I was going to say. Yeah, go on.
And cram it into the UTXO, right? And if you've done that, you're basically implementing group sort of after the fact, right? But since we have the opportunity to do it more cleanly, why not just implement it, at this point? And secondly, wait, can I say one more thing?
Yeah, go ahead. Sure.
So another issue is you're kind of screwing SPV proofs, right? Because, well, I guess you could give an SPV proof of the full transaction, and then, the client needs to apply the op return stuff to the appropriate UTXO, right? And now let's talk about UTXO commitments, right? So now, how are you going to do that when, again, you need the data is separated into two UTXOs, but the commitment should put the data into one UTXO, right? So it's creating a bunch of sort of problems that would need to be patched and fixed. And I think that it's it's possible though, right? And so it's just sort of a developer's opinion as to whether, you want to bite the bullet and do it more cleanly, or whether you want to sort of put in all these sort of patches and fixes.
Okay, I'm not actually familiar with the UTXO commitment issue. I should do more homework on that. That might be a killer. But the other things you said, from my point of view, it's a matter of where's the data. It doesn't really matter if the data is right next to the script, the output script, or if it's somewhere else in the transaction. You could always map it in the UTXO DB, like you said, somewhere else. There are some.
But that is inviting more changes, right?
Right.
So
well, that's the other point I want to make. So it's you're changing one thing to not change another. So the thing is, right now, if you change, if we have to throw out SLP v1 completely, that is a change, right? Like everyone that's got, infrastructure built, like they just have to throw that away and move over to group.
Well, actually, that's an interesting question. And what we're currently working on is presenting this information up through the existing SLP databases, right? And
yeah, I guess you could do that. Yeah, right. I think
you can totally do that. Now, the only issue is at some point, the wallet may say, please give me the raw transaction that underlies this SLP data, right? And at that point, we hand them the raw transaction, and the data is in a different place, right? So we can hide all of the details from wallets and users until they ask for the raw transaction. And then at that point, they would need a little bit of code to interpret and generate the op group rule set versus the SLPv1 rule set. I think though, if you're familiar with the SLPv1 rule set and you look at op group, you realize that the op group rule set is much simpler.
Yeah, it is. It wouldn't be a big change for wallets to just parse the output script and not have to parse the OP return. I mean, it's like, I agree with that. Okay, and the other thing is you're sort of, the fact that you're changing the output script, older wallets just won't understand it at all. They won't even know that address belongs to them, which is an advantage and a disadvantage, depends how you look at it. Either way, they won't be able to spend it, which can be a good thing.
I'm looking at it as an advantage to say, hey, the wallet cannot accidentally spend this transaction, right?
Right, which anyway group enforces, right? If there's no burn authority,
exactly.
You can't burn it without doing the proper output script. But it's like, for example, Fulcrum is going to break now, but it's fine. It could be easily fixed. It's just not break, but it's going to need to be changed. Whereas if you just preserved the OP return thing, it wouldn't. But that's just a minor detail. It's not a big deal. The advantage.
It's also worth if I may make a quick point, and then Imaginary, please go ahead. So just to be clear, I think like melting the token is something that the not having melt authority prevents, or burn, but you could still quote unquote burn the token by sending it to an address that cannot be spent from. Is that correct? Okay, just a small detail. Probably worth mentioning. Okay, so Imaginary, please go ahead.
So I have to say that so first I need to ask on the page on the details page, is that really all you have to present on in terms of details? I need to give benefit of the doubt by asking.
Well, yeah, I mean, other than the authority stuff, but which follows the same loop and check code, but it's I invite you to look at it. Obviously, I can't.
I did. I did. So
okay.
I will have to say that it is a very incomplete and potentially very misleading claim to say that it is simple and straightforward, because there are several aspects of it that are crammed into 2 lines, add detail and solution properties, namely authorities, the fenced BCH, the confidence, and the fact that the authorities can change confidence on the fly, and not to mention that we are also introducing a new number system that is not even mentioned there. Each of these changes warrant its own evaluation. It is a massive, complex change, and I'm very skeptical of the claim that it is simple or elegant or anything of that sort.
Well, I guess I would have to disagree. Did you say it introduces a new number system?
There is a raising of the integer limit unless I misread it and it is actually part of something else.
There's a raising of the integer?
I think he's saying that, big num and that sort of thing, which you have, I think, talked about while talking about group. And this is maybe something worth pointing out. Andrew, could you tell us, now we are actually running out of time because we'd like to get to questions.
Yeah, no, I need to clear something that is really important.
But yeah, please go right ahead and clarify if you'd like to. There.
Yeah, okay. So op group is currently implemented on experimental blockchain that I call NextChain, okay? It has big nums, it has all kinds of awesome stuff, none of which I'm proposing to go into Bitcoin Cash right now. No big nums are going in, no like op exec opcodes. There's so much stuff in NextChain that I'm not proposing to go in. So imaginary username, you might have gotten a little bit of a misunderstanding. What I would suggest that you do is go read the actual, if you haven't already, the Bitcoin Cash, the specification that I wrote.
I did.
Oh, you did? So, there is no use of the big num stuff in NextChain, and then there's no use of op exec or any of that proposed.
And so it's probably worth clarifying. So the original proposal listed many things. There was several pages of things that could be added once group was also added. And it was maybe not super easy to tell that it was not necessarily part of the proposal. In fact, it was even talking about the potential for a new transaction format, even though it also said there wasn't.
It also, for example, was the first proposal for transaction introspection, which is a whole separate effort that developers are working on, right? So the original group document was a 40-page document that basically looked deep into the future and proposed how we could get from where we were to like a full smart contract capable blockchain, right? What is being proposed now is a much smaller subset of that.
At least the authority part and the confident part are part of the proposal. Am I incorrect?
Yes. The authority
and
part.
Those
what was
and
your other...
they.
What was the second one? Imaginary authority and what?
It's the authority and covenants and their interactions.
Oh, covenant. Now, did covenants require introspection, or is that just looking at the first script, like the thing where it just looks at the script of the first group transaction?
Yep. All covenants does is say, hey, do the output scripts match the first grouped input script? You can imagine a simple loop that does that. It's implemented in like 8 lines of code.
Okay, and so imaginary, feel free to then comment on like even if so. Andrew's saying it seems to be pretty simple, but it seems you're at the very least skeptical.
I'm saying that each of them require their own consideration and evaluation. I mean, you can say that this is 8 lines, 7 lines. I mean, raising block size limit to 1 gigabyte requires very little change in code as well, but there is a lot more consideration that goes into it. And when they are put together in one massive proposal, I'm not sure presenting it as a very straightforward and very simple proposal is the right way to go.
Okay, Calin, yeah, go ahead.
So when there is a concern among the developers that maybe there's a lot of complexity that's IMUNIM is echoing here. What one potential thing that could be done is have this phased, like have the initial implementation just do basically SLPv1 semantics, you know, and then add on another phase later to add the covenant stuff or the fencing or, fencing seems useful and cool because then you could actually back tokens with real money. But I mean, would that be a path forward? Would that be something that makes people happy? It's just a question I have. Like maybe just do SLPv1 semantics initially, just mint, burn, spend, and then add on the complexity later after it's considered and after people are comfortable. That's just it's a suggestion really. What do you guys feel about that?
And then there is, I mean, it's not my place to propose, but there is also the elephant in the room, which is that how much value does it actually add does this entire scheme of complexity actually add on top of what we already have and are going to have soon, which is, on one side, we got SLP, which is non-consensus and easy to modify. And on the other, we have smart BCH, which adheres to an existing standard and can easily benefit from all the existing token and smart contract apparatus that are established somewhere else. Between those two, I'm not sure how much value that's.
Okay, well, maybe this would be a good point to then leave that there. And again, so if we can, I don't want to rush anybody, but I'm going to because we don't have a ton of time. So Andrew, if you could walk us through your trade-offs, we'll talk briefly about that and stakeholders, and then we'll try to get to a couple of YouTube questions.
Okay, trade-offs. So full nodes must implement a consensus change, but the change uses exactly the information already required to validate transactions. So there's no sort of new information needed. There's no reaching out and accessing random transactions in the UTXO set and so forth. Can be isolated into a single function, does not change any existing constraints. We talked about that. No database, UTXO, or block changes are needed. The SLP indexers should present group tokens as SLP-v2. We talked about this, that they can be done invisibly to clients, but one trade-off is until the indexer or the wallet asks for the transaction itself or goes to generate a transaction. Then it needs to understand something about group. One sort of detail is script hash indexers like Electron should ignore the group prefix so that when it does the matching, because obviously the group prefix with the amount field can change a lot, and the Electron script hash indexer was not meant to cover that, so it should just ignore it when it's generating script hashes. So unupgraded wallets will work fine, but as we said earlier, they won't recognize and cannot spend grouped outputs. So that can be a bit of a negative in the sense that it won't look like you're getting paid if your wallet doesn't understand grouped outputs. But if the wallet is imported via the 12-word secret key or whatever into a group aware client, then all of a sudden the tokens become available. The metadata will mirror SLP-v1, so that will be kind of easy. And the big trade-off, which no one's mentioned, but people have mentioned previously, is to have tokens on the blockchain means that there'll be more blockchain use, right? And perhaps that use isn't as high quality as it is if it was in just raw BCH in the sense of adding value to Bitcoin Cash, right? I believe that we can control that problem by perhaps changing the transaction fee for, token transactions if needed versus BCH transactions. But we are also, the scalability blockchain. So in a sense, we do have to put our money where our mouth is there and actually.
Sure. Okay. And so if I could just give, Calin and then Imaginary a chance to speak briefly, and then Andrew, sorry, if you can just keep track of what they both say, and then I'll give you one chance to respond before we move on. And I realize we might not get to all of this, and therefore, we can't. Of course, we can never really expect certain things to be completely resolved here. So as much as you can get would be great.
Mhm.
So Calin, if you want to get us started.
Yeah, I agree with everything that's on that list. It seems reasonable. The only question I have, it seems like there would be some database changes because you're adding sort of another UTXO space. You're adding the token reality, right? So there would be some. No.
There's no, unless you want to ask a question like, give me all the outputs associated with this token, you don't need to index by token ID, right? By group ID. So for typical like token operations, you can just use the normal BCH, UTXO space. But if you wanted to
just go back. Huh.
What?
All right, I have to think about that. Yeah, I guess that might be true. Okay, so you just go back to the previous output, look at the script, get the amount.
Mhm.
All right. Huh. Okay. That's true. I guess that's true. Yeah. All right.
Imaginary.
I suppose that depends on your interpretation, because you are obviously recording additional data and fields in UTXO. So whether that is a change, whether not indexing anything additional in UTXO, or is no change in UTXO, I suppose that is very up for interpretation.
Every
time someone creates a new transaction type, it's a change to the UTXO set. Like if I create a new script, I've changed the UTXO set.
Okay, well, I think that'll probably be a good way, maybe a place to leave that, so we can at least get to the stakeholders section. So Andrew, if you would go ahead, please.
Oh, okay. Well, okay, sorry.
Sure, no rush.
Okay, so I got two quotes from James Kramer and Barack. Wait, let me see if I can move this. Yeah. So, James said the group token upgrade would provide BCH with a token protocol that is scalable in a trustless way using SPV wallets. SPV1 cannot be validated using SPV alone. SLPV1, sorry. It requires users to validate the token chain locally, and this significantly limits the future usability of SLPV1 without relying on some trusted validation counterparty. Group tokens would eliminate this counterparty risk and also provide the ability to build feature-rich decentralized applications on BCH. Yay. And Barack of Swap Cash said, group tokens are by far the most streamlined proposal to achieving token-supported covenants, which could definitely help Bitcoin Cash unlocking its potential to mass adoption. Group tokens are not only needed for gaining user adoption, but also developer adoption. Builders need more scripting capabilities to building meaningful dApps, of which group proposal could definitely contribute to.
Very good, thanks. And then could you also maybe briefly, I realize this might be a big question, so however in depth you want to go. So these are people who have given you support vocally. Could you describe who in general you think the stakeholders are, whether they've spoken up about group or not? Like who are the people that are affected by this and will, or yeah, I guess who will be affected by this directly or indirectly?
People using SLPV1 tokens came to me because they were having serious issues with accidental burns and silent forks. And that's what sort of has brought group tokenization into focus again. And so anyone who's doing that, right? Anyone who wants to add additional and interesting features, I think, to Bitcoin Cash could really use group tokenization. I think it's
okay.
People, as I said, I don't know, people don't seem to understand this analogy, but I see, blockchains are a language, right, for communication of, ideas about holding value, right? And currently we have one noun in that language, which is BCH, right? It's very difficult to sort of build an interesting conversation with one noun. So anyone who wants to create a service to sell tickets, to sell coupons, to, you know, hypothecate any security, right? It's a huge, huge field. So I think there could be potentially a lot of stakeholders, and we don't necessarily see them because they're on other blockchains right now.
Sure. And then Calin and Imaginary, would you like to either comment on stakeholders you think he's missed, or potential people that would be, you know, affected by this indirectly?
Calin, yeah.
Stakeholders that we've missed, I guess like the big, like Bitcoin.com, I think they're pretty, from what I understand, they're positive on group. I shouldn't speak for them, but I don't know what other stakeholders to think of. I mean, there's developers, but they're not really stakeholders. They're just,
well, and I would say they are, at least to some degree. And
bit.
so maybe we're even thinking groups of people, as opposed to specifically say Bitcoin.com. You can say, okay, people providing X services, Y services, Z services, people, that sort of thing.
Miners, but they,
Sure.
I think miners are pretty agnostic. I mean, I think they would be happy with anything that increases adoption. So if group lives up to its promise, I mean, the proposal says, oh yeah, we're going to maybe hopefully increase adoption. You know, miners would be happy with that. I would imagine. I can't speak for them, but I mean, from my perspective, I think SLP doesn't scale. So anything that's better, you know, that can be validated by SPV without having to do a whole DAG walk, going back to the whole history, chain of custody. From my perspective, I'm happy with that as a developer. So that's all I can say. Whether it's group, whether it's something else, it would just be something. It'd be nice to have not have to deal with validating a whole chain of custody to the beginning of time. I mean,
sure. Thank you. Imaginary, you want to go ahead?
To me, because of, well, the interpretation differs, but to me, this is a massive change that can significantly impact how the BCH blockchain works in the future. So the potential stakeholder group is basically all the major pools and businesses that are currently on BCH. One thing that is perhaps also in the interpretation difference is that I don't think the BCH blockchain is a system on which, you know, BCH is just a noun. The BCH blockchain is a tool that's, you know, serves several desirable properties to BCH, the currency, which is at the dead center. So you know, those all the other potential people who are establishing tokens should be viewed in the context of how they benefit or bring cost or risk to existing BCH stakeholders. That's basically.
Could you give us just maybe an example or two of the type of risk that would bring specifically to, say, businesses or something like that? Like are there any concrete risks you can describe, or even types of risk that come from changes of this sort?
We discussed at the very beginning, there is the risk of complexity bringing upon undesirable forks or denial of services. Those risks that previously affect only the token system, and sometimes not even the token system, only one particular token. In the case of SLP, if risks are isolated, they now affect the entire blockchain, whether you care or not. So that is one risk. There is also the risk of additional maintenance, and I can go on, but you get the idea.
Well, I mean, if there are any specific ones that are pretty easy to describe, I'd love you to just, you know, sort of list them off. But if that's it, then we can move on.
There is also the other point of disagreement that was brought up before, which is that it doesn't affect existing consensus. Adding consensus rules, adding constraints is definitely affecting consensus, and it's a bit misleading to say that it does not affect consensus just because it doesn't eliminate any existing rules.
And that may have been a wording issue. I think it said it doesn't affect existing consensus. Is that what it was?
It does not affect existing consensus.
or even existing consensus rules may have been the specific
But-
wording.
So it
Practically,
sounds like,
practically.
Imaginary Username and I disagree about a few things, but I will say that he's gotten to the heart of the matter here in terms of his previous point, which is, bringing group tokenization or tokens into the BCH blockchain, is a big concept, and it potentially creates a giant market, right? But it does come with some risks that, Imaginary Username did succinctly mention. We are adding new rules. There could be bugs in those rules, right? So, the listeners do need to consider a trade-off between the size of the market and the potential versus changing anything, right? And I think I've made kind of a good argument that the changes are, conceptually at least, much simpler than something like Schnorr signatures, right? But they are changes. So.
And the one thing I want to bring up again is the elephant in the room, which is that for all the benefits that we talk about in terms of tokenization, smart BCH exists and needs to be brought into context. What additional benefit do people have on top of that? So when considering cost versus benefit, I think that is something that we simply cannot get around.
Okay, and that actually transitions us nicely to. I'm sorry, what was that?
People are getting a bit excited about smart BCH, but I would have a bit of a different take, which I just don't think it's actually that wise of a business decision. And the reason why is because, Ethereum, like if Bitcoin Cash didn't scale, then you could imagine sort of that Bitcoin Cash was Bitcoin without the first mover advantage, right? Bitcoin without all of the, all of the press on mainstream media. And that is what is, in the last 4 years has been killing our price. So what is smart BCH going to be? Ethereum, but not Ethereum? Ethereum without the first mover advantage? I believe that Vitalik will solve the scaling problems in Ethereum. So what are you going to end up with in smart BCH? Again, you're going to end up with a side chain that people who use Bitcoin Cash might take advantage of. But if you're a new entry wondering what to put your thing on, you can either choose the real thing, Ethereum, or a derivative. Which one are you going to choose?
Sure, and we'll probably leave it there. I realize we might have a response, but let's keep on going. So that was actually one of the questions. So I'm glad we touched on that, about the situation with smart BCH. Mr. Corrupto asks, what will be the case for what is now the document field in SLP? In a first-class citizen solution for tokens, will something like this be supported or even expanded beyond?
So our intention is to use the exact same document field in group tokenization as in SLPv1. Actually, ironically, the SLPv1 came from the original group tokenization proposal. So we're kind of all in alignment on the documentation aspect of it.
Okay, from Zesto. Oh, I think I know who that is, but I forget his name. Will OpGroup remove, or will the group tokenization proposal, which I'll mention that very quickly for our viewers. The original proposal, correct me if I'm wrong, was called OpGroup, and this is called the group tokenization proposal, which is the updated version that does include an opcode called OpGroup, but the proposal itself is not called OpGroup. Is that right?
Yes, because it was expanded to include things like authorities, which give you really interesting and important features like key material rotation and stuff like that, right? So the original OpGroup proposal was very much a minimum viable product that was intended to capture the tokenization craze in 2017 and could have been delivered, extremely quickly and easily. But when that didn't happen, there was time to make a more fleshed out solution that really covered all the bases.
And so they're asking, will OpGroup or will group tokenization remove all complexity needed for SLP, SLPDB, MongoDB, etc.? Or will it just replace Operature and SLP with one op group instruction? I guess maybe even the more fundamental question is SLP v1 like supposed to disappear at this case once SLP v2 exists via group?
Yeah, I think there would be a compelling argument that it would no longer be needed. However, Electron exists as a protocol for a reason in Electron servers, right? They're technically not needed. You can get all the information about BCH by accessing the peer-to-peer protocol, right? But these higher level databases have advantages, right? So SLPDB doesn't need to be consensus correct anymore in terms of the SLP stuff, right? But in the sense that it's presenting the tokenization data very elegantly upwards to clients, in that sense, it remains valuable.
I can chime in here too. One key thing is if you're implementing a wallet right now with SLP and you want to really validate correctness, because you may not be able to trust the data source. Like the data source is telling you I'm getting like 5 spice or something. Like you don't know really if you have 5 spice without actually validating fully or making the decision that you trust the data source. Whereas with minor validated tokens, you can trust the proof of work. You don't need to trust anything else. So that's one difference. It actually would get simpler. Like a lot of you'd be able to do mobile wallets that are just more secure. They don't have to do all this downloading and validation themselves. I think you'd probably see more mobile wallets with SLP tokens and with tokens in them as a result. So it would simplify things. To answer that question, it would simplify a lot of things to have this or something like this.
Okay. Free Trader says, so there are currently something like 384,000 token contracts listed on Ethereum alone. Clearly the demand for tokens is very large. And then he says, some amount of state tracking will need to be done for group. I did not find much information about the storage impacts of this state and possible architectural implementations or design suggestions for doing this. Now, does this come back to the fact that it's all the UTXO set still and works that way and doesn't require any separate
Right, it doesn't require additional state, right? It will expand the UTXO set. And this is why, the dust limit is still enforced. Like if you have a group token as a UTXO, you have to put a tiny bit of BCH in it, which matches the current dust limit for BCH, right? So, if you wanted to spam the blockchain, you could do it with BCH as easily as you could do it with tokens, right? And then there is an additional about 40 bytes per output. So that's really your hit. But let me also observe though that, tokens tend to follow, like a exponential use pattern, right? So there's a few tokens that are used tremendously and then most of them are not used as much, right? So, it's 1 over some, X squared or something. So why is that useful? Well, because you wouldn't have to store that or even transmit it across the network, that 32 byte group identifier every single time you see it, right? You could just compress it, right? And say, hey, it's, you say, use like a Huffman encoding, right? And just say, this particular group ID is the most prevalent in the last 1,000 blocks. So we're going to call that, a 2-bit value 1, right? And then you just create a Huffman encoding tree, right? So then you can actually compress the group ID hashes significantly.
And then a second question from Free Trader. Yes. Also, have performance tests been run with group, possibly a simplified or limited phase 1 scope on something close to BCH? My understanding is that NextChain already diverges in several other points, but perhaps performance tests there could offer some insight. I just haven't seen much published on that, so I'm asking where to look.
Yeah. So we haven't run explicit performance tests. Part of the reason why is because the algorithm is quite simple and it is no more complex than the current, analysis of transactions, right? So from a big O perspective, it can't be more than sort of a linear amount harder than current transaction analysis, right? That certainly is work to be done just to sort of dot the I's and cross the T's, right? And if there's interest in group tokenization for BCH, the first step would be to isolate it and move it to sort of a more formal pull request into BCH, right? And then it would make sense to test that from a performance perspective.
Very good. From Jonathan Silverblood. Now, this again may touch on the storage and UTXOs again, but he asks, in order to mint melt, they need to track what authority inputs are being used, right? So some data has to be stored somewhere.
So the authority is itself a UTXO, and it's just one with a, if the quantity is negative, it's interpreted as an authority quantity field. And so if you spend an authority, you gain that feature inside your transaction. So there's, again, no separate database needed to track authorities.
Let's see here.
And that's how key rotation is also implemented too, by the way, because, key rotation is the idea that you're a company and, you have a couple people who control, say, the minting of an important token, and one of them leaves and you bring in a new VP of whatever, right? So you need to, change who owns the authority to, mint this token, right? And so if an authority is controlled by a UTXO, then you can spend the UTXO to the other individual, right? Giving him the authority.
And then Benjamin Sherry asks, he'd like to ask imaginary username if there is any concept of token support that he would support. I assume he means minor validated, but I don't know for sure. He says, I get the impression that Imaginary's criticism isn't about the implementation challenge of group, but the entire concept.
Actually, no. There are. I can certainly imagine that some very, very stripped down, very simple token proposals. For example, a few opcodes that live strictly in input script is possibly the simplest example that I both wouldn't mind and perhaps would just ignore that they even exist, because they make very, very minimal changes to how BCH currently works that they would essentially just be another opcode that if you don't like it, forget they even exist. So it is not true that I am against any tokens or against any consensus, any tokens that are validated in consensus rules one way or another.
And just to be clear, I think he did mean the entire concept of group as opposed to any others, as opposed to the entire concept of adding tokens, but I'm not sure. He can let you know in private if that's the case. Okay, so let's see. So one last one. Matthew G mentioned, so Andrew, you mentioned that you're aiming for November, and there has been talk about, move to a 1-year schedule, or even just at least now, taking some time. Andrew, would you like to comment on just the schedule, and if, particularly you supported the 1 year or moved to 1 year, or just the initial 1 year of waiting, and then maybe Calin and imaginary username could also comment on that if they like, and we'll finish up.
Right. So this is an issue that's broader than group tokenization, right? We're sitting here looking, and sure, there was a kin.com pop in BCH recently, but, let's ignore the last week, and we're looking at, several year leakage of value and, interest out of Bitcoin Cash, right? And so I actually believe that we need to move more aggressively and faster to create excitement and interest in our coin. And so obviously, Bitcoin Unlimited is not the hash power majority. And so we don't control when these features come in and so forth. But I believe we need to move faster. And so that's why I'm hoping for, November timeframe.
Very good. And then Calin or imaginary, would you like to comment on the schedule?
I'm agnostic. It's really about what other maintainers can do. I can do November, I can do May, it's really what the ecosystem wants, and what other maintainers and other developers think they can do. And I'm okay with any, like, I'm agnostic about it, basically. I'm flexible on that.
Imaginary?
So I mean, I'm the original guy who proposed moving to a 1-year schedule. So you probably already know where I stand. But the justification for moving to a longer schedule is that we were on a 6-month schedule, and it had terrible records such that BCH suffered not from a lack of excitement over features, but from a lack of confidence altogether. And that is not something that can be addressed by any given feature, even if, it is the bee's knees throughout all of crypto. It is revolutionary. None of those features will address a lack of confidence, and every time any shenanigans, whether technical or political, happens that threatens people's confidence, we are that much further away from peer-to-peer electronic cash for the world, and that is what I'm most concerned about.
Very good. Well, thank you all very much. That's probably a good place to leave it. I'd like to, thank everyone for joining us. I kind of ruined my exit script, but I'll read it anyway. That concludes today's Bitcoin Cash network discussion on the group tokenization proposal. These network discussions are hosted on a best effort basis by volunteers, so thanks to everyone working behind the scenes to make them happen. Thanks also to bitcoincashresearch.org for providing the online platform where these discussions can first form. If you have a proposal for the Bitcoin Cash network, bitcoincashresearch.org is a great place to start. And thank you for watching. Subscribe to Bitcoin Cash Network Discussions on YouTube so that you don't miss the next discussion. Leave us a comment letting you know what you think about group or what you think about the Bitcoin Cash Network discussions themselves. Thanks again, you guys, for joining me.
Thank you. Thank you very much.
Thank you.